All right, everybody. So we're starting here on our homework that I gave out the other day, and we're just checking this. So I kind of already started this, but now I'm going back to it. So if I go right here, it says dad is homozygous dominant, right? Homozygous dominant is big B, big B. We drop that right here. Mom is heterozygous, big B, little b. We drop that right here. We fill out this Punnett square, and we see that we get big B, and a big B, big B. So we get 2 out of 4, right? 2 out of 4, that's 50%. So our genotype for big B is there's a 50% probability of getting that. And then we also have another phenotype genotype that we have here, and that's big B, little b. So we go big B, little b, and now there's a 50% chance of getting that big B, little b right here. So then our phenotype is the physical features, right? So right up here it says brown eyes is dominant, and then it says blue eyes is recessive. It doesn't say that, but it says the uppercase B equals brown eyes. We know that uppercase letters symbolize the dominant allele. The lowercase letter represents the recessive allele. So then what's our phenotype? Well, here we have a dominant allele. Our dominant allele is brown. Our phenotype is brown. And so anytime you have a dominant allele, that means it's going to be brown, or it's going to show that dominant allele. So this guy anybody that has this genotype will have that dominant allele, which is brown eyes. This guy has a dominant allele as well, even though it's only one. Right? This guy will always mask the recessive allele. And so they will also, this individual or anybody with this genotype will also show that phenotype. And so all of these individuals have a big B or have the dominant letter. And so that means 100% of them will show the brown eyes. There's a probability of 100% all of them will have that. Okay, next. Curly hair is recessive. Straight hair is dominant. Okay, so we got that out of the way, right? So then it says a woman with curly hair. And so back here it says curly hair is recessive. And so the only way to show a recessive trait is if there's no dominant trait masking it, right? So the only way to show a recessive trait is if we have 2 recessive alleles. So we know this woman who has curly hair, she must have this genotype right here. So let's go ahead and fill that in. Okay, you guys need to get to doing that, okay? So like when we do the quiz and stuff, I would go ahead and write this genotype in where you see the actual individual. And then she married a man who is homozygous dominant. So homozygous means the same, and it says dominant. So that must be a uppercase. Okay? Homozygous, they're the same. Dominant, they're both dominant letters. And so this parent goes right here. And so we have big R, big R, little r. And so every single one of these in here, all 4, are big uppercase, lowercase. Okay, so our genotype again, big R, little r, that's 100%. And it has this our dominant allele, right? So it will show a dominant trait. So what's the dominant trait? Straight hair, it says right here, is dominant. So that means 100% straight hair. All right, number 3, you didn't have to do. Number 4. So attached earlobes is dominant over free hanging earlobes. So complete the Punnett square. So it says mom right here is big B, and dad is homozygous recessive. So if we cross these guys, so we see again that we only have one genotype, and it's this big B, little b. We have no other combination of alleles. So this will give us 100% big B, little b, because there's no other combinations in here. And then our phenotype, so again, we have this dominant allele, and so it will show the dominant trait. So what's our dominant trait here? Attached earlobes are dominant. Okay, so that must mean that 100%. Sorry about that. 100% have attached. 100% then must have attached earlobes. What's going on here? Right. Computers fighting off viruses. Well, I'm glad it's got to do this while I'm doing my video. Okay. So let's go ahead and flip it over to the next side. So it says right here, freckles are recessive, no freckles are dominant. So mom is heterozygous. Heterozygous means different. So that means we must have one dominant, one recessive. That's what it means by being different. Then homozygous, so they must be the same, but it says recessive, so that means they both must be the same. But if they're recessive, that means they're both lowercase. So I'll bring this author right here, homozygous recessive, this heterozygous here. All right, then we cross them. These guys come down. These guys go across. Little h goes across. And so we see that we have this big H, little h, big H, little h. I did this backwards, usually the dominant allele. I should have done that. The dominant allele comes first, followed by the recessive allele. So 2 out of 4 have the big H, little h, so that would give us a 50% chance. And then we have our little h. And again, 2 out of 4 have a 50% chance. And so then these two are going to have different phenotypes. So because this guy has a dominant allele, but this guy has no dominant allele, so they will have a different phenotype. So our dominant phenotype, because we have a dominant trait here, are no freckles. So this one would be no freckles. So 50%. So 50% have no freckles. While then this guy, they only have recessive alleles, and the recessive are freckles. So then the other 50% have freckles. So then we move on to our vocab. Our vocab, recessive alleles. So F, represented by lowercase letters, will only be showed if paired with similar allele, and we just showed that here, right? These freckles will only show if both alleles here are recessive. So that's, oh, sorry, wrong one. So that is F. Number 2 is A. Genetics is a scientific study of heredity. Number 3, genotype. Let me see here. Number 3, genotype is H, the specific genetic makeup or code for any individual. Number 4, Punnett Square, which is G. A Punnett Square is a chart they use to calculate the probability of an offspring's combination of alleles. Number 5 is dominant alleles. It should be E, represented by capital letters, and will show up if present. Heterozygous, 2 paired alleles that are different from each other. See, so that's our big H, little h. Dominant would just be an uppercase, right? Heredity is then the passing of characteristics from mom to offspring, or from parent to offspring. Phenotype is the physical appearance for an individual. And then homozygous, 2 paired alleles that are exactly the same, which is D. So that can be homozygous dominant or homozygous recessive. All right, recessive alleles would look like that. All right, moving on. So that was our homework. And then today, all we did really was we practiced. So I handed out this sheet here, this little, it's not really a packet, it's got 3 problems on it. So we did this one together. And so go ahead and pause this video and work this out together. And I'm going to go ahead and work it out. And then you can play it after you get done finding it out on your own. Okay, so it says a male and female bird have 4 unhatched eggs. The female is on the left and is heterozygous. So remember, heterozygous means different. So it says the female's on the left and she's heterozygous. That must mean this is big H, little h. And then the male on the right over here is homozygous. So homozygous, remember, is the same. Recessive, so the same recessive. So it must be little h for this guy. And he's the recessive. So what's the genotype of the female? Well, we already wrote it down, right? Write it down as you read it so it's right here in your head. or you don't have to have it right here in your head. You can just look at it. So anyways, this female is big H, little h, and we already did the male. Which color is dominant, gray or black? And so gray is dominant. How do we know that gray is dominant? Well, the female is gray. The female's gray, and she has this dominant allele. So anytime that allele, that dominant allele is present, even if there's another allele, that dominant allele will always match the recessive allele. Okay. And so that's how we know. So it's the female because she has the dominant allele. D says write the phenotype of the female and the phenotype of the male below. And so we know that the female is gray. And we know that the male, if he's on the right, is black. So then we run out this Punnett square here. So we just grab these two genotypes up here. So big H, little h, little h, little h. Start filling it out, start filling it out. This little h goes here, this little h goes here to here. All right, so if the following Punnett square ratios follow the Punnett square ratios, what will the babies in the eggs look like when they hatch? Well, we'll have this big H, little h, and this big H, little h. They have the dominant allele. So we know that 50% will be gray. And then we have little h for these two. And we know that the recessive is black, so 50% will be black. Okay, and that's if they adhere to the Punnett square, right? So it doesn't matter. Every single time that a baby hatches, there's a 50% probability of it being gray or of it being black. Okay, even if we had 3 babies in a row or 3 chicks in a row that hatched as being gray, that 4th egg still has a 50% probability of being gray as well as being black every single time. So what will all 4 spring? Will all 4 offspring adhere exactly to the ratios predicted by the Punnett square? No, in real life that doesn't actually happen, right? It's just like a coin toss. It says this right below. If I flip a coin and I get 5 heads in a row, what's the probability of me getting heads again on the 6th toss? It's still 50%. If I flip heads 100 times in a row on the quarter, what's the probability of me flipping heads again on the 101st try? It's still 50%, and that's what I was trying to say here. So you can still have all of your offspring. You could have 4 different chicks, and all of your offspring could all be black and have that recessive trait. It's just we're predicting, right? And predictions don't always come true. All right, so then this next one. This next one's kind of tough. So here we're looking at these fish, and we're working backwards. So we look at what the offspring look like. We see what the parents look like. So we can see the phenotypes, but we do not know the genotypes. And so that's what we're trying to figure out here. What are the genotypes? So right here it says the fish resides in tank. There's an instructor while board decides to determine the genotypes of the parents based on the back fins. So we see these back fins that the parents have here. All right, so we see these back fins. So all of these offspring have them, right? Until we find this guy right here. We see this guy has no back fin, and then we see this guy up here has no back fin. Well, if you notice, let's look at how many offspring there are. There's 1, 2, 3, 4, 5, 6, 7, 8. Right, there's 8 total offspring. Out of these 8 offspring, we have 2 of them that do not have a back fin. Well, this is weird, right? Because both parents have back fins, but 2 of their offspring do not have back fins. So where the heck did they get this trait from if their parents didn't exhibit it or their parents didn't show it? Well, let's figure this out. So we must have a genotype. We must give the parents a genotype that give them the same looks, right? Their same phenotypes. And so what are some combinations of genotypes that would give them the same? Well, it depends if it's dominant or recessive, right? We don't know yet if the back fins are dominant or recessive. And so since this problem, we're all looking at if they play out, if the offspring play out like the Punnett square says it will, then we should get this, right? And so we should see that all of the offspring, or 3/4 of the offspring, have a back fin, just like the parents. And so this is how we know that back fins are dominant, because both parents have it, and they pass it on to 3/4 of their offspring, and then somewhere along the line, right, two of their offspring did not get that trait. And so what's going on here? So the dominant phenotype must be back fins. The recessive must be no back fins. And so I actually like to jump down and do these Punnett squares first. And so if I put my parents here, right? My parents go right here. I need to come up with two genotypes that will make my two parents look the same. Well, if I do little b and big B and big B, and little b, right? What do we spot wrong with this already? Well, I know that we have a dominant allele here, so this guy will show the dominant trait. This is recessive, so this parent right here will not show the dominant trait. So that means that these two parents would actually look physically different, right? So we know right off the bat that that's not going to work, okay? Now let's go to another one where we might get that. So let's try with big B, and big B. Okay, so these two parents will look the same, and they will both have that show the dominant allele, right? So let's see how this one will work out. Big B, 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 big B. All right, so what's wrong with this one? Well, the only thing wrong with this one is all of the offspring will have back fins. But we have two offspring up here that don't have them. So how does that happen? How do we stop and figure out how do these two offspring, or how does this, if we change this 2 to 8, this is 1 to 4, and we know that that's 25%. So how do we get that? How do we get 25% of the offspring will show a different trait than the parents and the rest of the offspring? Let's try this one out. Let's try a heterozygote. Big B, little b. So we know that this guy will exhibit the dominant trait because he does have a dominant allele. And let's get the other guy in there. This guy will also have the dominant allele, and he'll also show the dominant trait. So let's go ahead and work this out. So we have a big B, big B, big B, little b, big B, little b, and then little b, little b. All right, so let's go ahead and check this out. Well, we already see this guy right here, this square. This is our homozygous recessive, right? He will look different from this parent and this parent. And we know that there's a 25%, right, 1 out of 4, there's 25% probability that we'll get offspring that look different than the rest of the offspring, right? Even though this genotype's different, this guy will look the same as this guy. This guy will look the same as this guy. So we know that 3/4 of them will display that dominant trait, and the parents have that dominant trait. So this looks to be the winner. So our two possible genotypes, so what we do want is this guy right here. So this is the one that does work. Both parents do have this genotype of heterozygote. A possible other one would be this big B, big B. But we know it's wrong because we ran it out here in this Punnett square. Okay? That was possible because we know that the parents exhibit the dominant phenotype. So anyways, here's the one that we're looking for. There's our Punnett square that we want. So then it says, what are the genotypes of the parents? The genotypes of the parents are big B, little b. Then H says, why are the other Punnett squares not possible for this family? Well, let's check this one out. Let's say we bred two homozygous dominant birds, or sorry, what are we on now? Fish. Okay. Homozygous fish together, homozygous dominant fish. Then that means that there is no recessive allele to pass on to the offspring. Thus, you can't get a recessive trait in the offspring. So if there's no recessive allele in the offspring, then there's no way to show that recessive allele, and the vice versa. If there's no dominant allele going on to the offspring, then there's no way that offspring will display a dominant trait. Okay, and so how are we going to write this? Let's see. If even one parent was homozygous dominant, even if one parent was homozygous dominant, then all offspring would show that dominant trait, and we could not get a recessive phenotype. All right, so there was our practice that we did today. Bam, right there. What you guys have to do for Wednesday is this one right here. I gave this one to the other classes. This is all you have to do. So finish this one up, bring it to class on Wednesday, or if you're not here yet, just submit it. And we do have a quiz on Wednesday. We were originally going to have it today. I was like, no, we need a little more practice. So today we practiced. And now Wednesday. Wednesday will be the quiz. You get it done. All right. We'll see you. Let me know if you have any questions.